Hello everyone. So in this lecture we are introducing Simulink. So Simulink is a software package and is a graphical extension of MATLAB for modeling, simulating and analyzing a variety of dynamical systems under a graphical user interface. In Simulink, model of the system are drawn on screen as block diagram. It includes a comprehensive block diagram for creating standard components such as sink, source, connector, linear, and non-linear component. To make a model for any particular system, the component requires for the model are selected from the library browser and are then dragged and dropped into the Simulink window using the mouse or the touchpad. It is integrated with MATLAB and data can be easily transferred between the program. Now for starting Simulink, uh, it can be started by using any of the method. It can be started from the MATLAB prompt by writing the following command in the command window, that is writing. You can write Simulink. You can open Simulink by writing simply writing Simulink and then click enter, and this will open Simulink. Or another ways to open the Simulink is this will open the Simulink libraries in which you can see the blocks, or you can directly click here, that is Simulink library. This will also open the Simulink. You can see here there are so many toolboxes are there as per your requirement or the field in which you are working. You can use the toolbox, but there are so many toolbox. You have to be concise and do your research work in particular domain. So in the Simulink there are some commonly used blocks are there, in which we have bus creator, bus selector, and a constant input, data type converter, and delay element, demux. Demux is basically used to separate out the inputs. Discrete integrators, discrete time integrators. These are some of the basic blocks which you can use in the continuous library. You can see here that uh, some of the blocks such as derivative, integrator, differentiator, PID controller, and 2 degree of freedom PID control, state space modeling, transfer function modeling, and there are some delay element are also available in the continuous. In the discontinuities, you can see these are the non-linearities which you can use in your system, such as backlash, dead zone, dynamic dead zone, and so on. In the discrete library of the Simulink, you can see that there are discrete delay element difference, discrete derivative, all the components related to discrete time domain are embedded in this discrete library. For the logical operation, you can select uh, any of these block set for performing the logical operations. In a similar way, for performing the mathematical operation of addition, subtraction, and multiplication, division, you can choose any of these block for creating your system. In the same way, model verification, you have different check static gaps, check static range, and others. And port and subsystem are used to make a subsystem part inside the Simulink. For these are for these are the blocks which are used for signal routing. These are some sinks, that is display, scope, and these are the sources which you can use in your model, such as constant source, clock, which are required to simulate any model. And after that, there are some particularly specialized toolboxes are there in Simulink, or that is libraries are available in Simulink. This is the library for, when I first drag it out, this is the library for aerospace block set that might be used by aerospace engineer. This is for communication system, and this is for computer vision and toolbox, and this is for control system. That is LTI linear systems. This is for DSP, digital signal processing. Same is that is for data acquisition. This is for embedded systems, and this is for fractional order systems. There are multiple sets of these toolboxes are available, and as per your requirement, you can use uh, in your field. Generally, so the my specialization is in control, so I can use these the common commonly used blocks, sources, sinks, and port and subsystems. But for other applications, for the signal processing, you can use DSP toolboxes, and for aerospace engineering, you can use aerospace block set. But in this course, we are confined toward control system and designing and simulating the real time or dynamic system. So let's first start with creating a Simulink model. You have to click on this new model. When you click it, an untitled file is opened in which you can drag and drop any means any block and try to simulate and see what are the response for these block. Let's take some source and try to add it into the untitled. Let's take this pulse generator and take it ramp. Sorry, this will open the help. Let's try to add it into the untitled. When you see this untitled, you can see here that there is a ramp block is added, and also a pulse generator is added. When you look at inside this, when you double click on it, you can see you can change the parameters, that is slope, start time, and initial output. So slope we have considered 1, and start time is 0, and initial output is 0. For the pulse generator, you can see here that amplitude is 1, period is 10 seconds, pulse width is in percentage, that is 5%, or you can consider it as 50%. Try to take one sink, that is source or scope. Let's try to check one by one what is the response of this ramp signal. To run this model, you have to click on this button. This will run for 10 seconds. This is the time duration for which the model is simulated. When you click it, run, You can see this will run and the waveform is stored in the scope. As you can see that the axis for the time is from 0 to 10 second, and that for uh, RAM signal it is this is the output Y of the signal, that is 0 to 10. So this is the waveform of the RAM, which you can clearly see here. You can zoom in and zoom out the waveform. There are so many advanced features available in Simulink. So if I want to see what pulse generator will generate when you run it, this will give you a 50%, that is for the 5 second the waveform is 1, and for the next 5 second it is 0. You can expand it or auto scale it by using this button. This will give you the value 1 and 0. For the first 5 second it is 1, and for the remaining of the 5 second it is 0. Now you can perform different operations on these signal by using mathematical operations. You can select product, you can select divide, anything you can perform. So let's take some first product. We just try to product these two signals and see what is happening over here. When you run it, this will give you the multiplication of the two signals. You can see here that this is the multiplication of the two signals. Now you can perform addition, subtraction, both, or any other combination you want. For addition, let's take add, delete first this. You can put this inside. This will connect automatically. So this is the addition. This will give you the addition of the two signals. We can also perform the subtraction by replacing the plus sign with minus. When you run it, you can see here that this is the subtraction of two signals. So this is the subtraction of the two signals. Now we can take derivative of a particular signal by including the derivative block inside this. You can go here, add to the untitled. Just put a derivative sign over here and remove this, as well as remove this and this. Try to see this derivative of this particular signal on the scope. When you run it, you can see the derivative of this particular signal, and this is the derivative. The value is 1. That is, will give the value slope of that particular signal. I hope these operations are clear to you. You can also perform integration on the particular signal. Just delete or cut and save for the later use. You can see or check how the integration of this signal will look like. This is the integration of the particular signal, that is the RAM signal. Now you can perform any operation. You can add or a constant, or you can add a variable quantity to a particular signal. So let's try to integrate and differentiate a sinusoidal signal. So let's add sinusoidal signal from this. Here you can see the sinusoidal is there, sine wave is there. You can connect it. When you check it, the integration of sine will give you the cos wave. This will give you the, when you try to differentiate it, this will be the result of differentiation of the sine signal. You can change the signal by double clicking on this, and you can change anything, that is amplitude, frequency and phase of this particular sine signal. So let's take frequency around 10 hertz, phase 0 and amplitude 1. When you run it, you can see the multiple cycles over here. This will not give the proper result just because of the sampling time. So you can change the sampling time by going into the simulation model configuration parameter, selecting fixed type, taking Euler 1 and taking the sample time to be 0.001. Then you apply and OK. When you run it, I think this will give you the better result. So I think this looks like a cos waveform. See here that the frequency is 10 and amplitude is 1. When you differentiate it, the frequency is comes out from inside to outside, and the amplitude will become 10. So this will give you the amplitude 10. If you take frequency as 1, this will definitely give you the cos result, cos waveform. You can see here that the waveform is not what's regularly a cos waveform, but after, sorry, this will not showing in the axis. The axis is from 5 to 10. So to increase the axis, you have to change the setting. History, limit data point will be disabled. Now try to run it again. The data point will be increased, and you can see here that this is the particular cos waveform for that sinusoidal signal after differentiation. So I hope this differentiation and integration are clear to you. Let's again try to check integration for that. a particular sine waveform and you run it, you can see here that this is the integration of the particular sine signal. You can compute it mathematically, it will give the same result as mathematically. Now if you want to check the differentiation of this pulse, or integration of this pulse, which will give you this result. Now if you want to see both these signal, that is the output of this integrator and as well as this input on this particular scope, then you have to use a multiplexer over here. Now add a multiplexer, remove this wire or connection. Now you can check this input as well as this output on the same scope simultaneously. When you run it, you can see here that the purple one is the output of the integrator and this yellow one is the input. That is a pulse waveform. So I hope this is clear to you. Now you can use discontinuity block. Let's try to add a discontinuity, that is saturation. When you apply this and limit its value to 0.5 to minus 0.5, input is when you applied it to the input, you can see here that this will be the input part and you have applied the saturation here. Then the value of out input will not go beyond 0.5 and not go below minus 0.5. When you run it, you can check this is the input and the value is 0.5 for the input and the lower value is 0, which is above minus of 0.5. So I hope the function of cascading two blocks is clear to you. Here I have cascaded integrator with the pulse waveform, and in this link or in this path we have integrated a saturation. So different types of operations you can perform to your signals. Here you can see there is a gain. You can use this gain and multiply the pulse generator value with 10. Please change its limit to 100 so that you can check the changes in the effect of this gain in the pulse generator. When you run it, this will give you pulse width of 10. The amplitude of the pulse is 10 and the lower amplitude is 0 because 10 multiplied 0 will give you 0. So these are some basic operations which you can perform on your signals as well as on your you can apply your uh, basics on particular signals. Now we can delay a particular element as well by considering this unit delay. You can delay a particular element. When you apply it, of one element is delayed, every element is delayed by one. But due to number of there are large number of samples, so it is not visible. But the element are delayed. So this is the some of the basic operations or basic fundamental operations you can perform on any signal which you want. Now you can perform division, multiplication, dot product or absolute of any signal you want. So let's take one more example of absolute. Let's try to make absolute of the sine signal. Just control C and control V. This will uh, give you the mu scope. When you run it, this will give you the absolute of sine wave. It looks like to be a full wave rectified result. Full wave rectifier result. I hope you have studied full wave rectifier in your BTech study. So this will look like a full wave rectifier output. Now you can perform any other mathematical operation on this. Let's take, you want to make exponential of u. You can embed this, and when you run it, this will give you the exponential of sinusoidal signal. You can take square root of, but square root in negative will give you the complex number, but the complex number cannot be plotted on that plot, so we'll give you the error. Let's try to check. So I have deleted this and place this is square root. When you run it, this will give you, see here that it will neglect the negative part and just square root, give the square root of the positive values only, as this scope will not represent imaginary values. So this will Simlink will skip this and will take only real values, positive real values. So calculating the square root of this particular signal. We can sum also, sum of elements. Whatever be the element generated will be summed and shown in the scope. When you run it, you can see that this is a sum. There is another mathematical operation that is you can use is divide. For divide, you can use this block. You can divide this signal by a constant value. Let's take constant. It will be found in commonly used blocks. Add to untitled. Divided by this sinusoidal wave is divided by a constant value of 10. When you divide the maximum amplitude, that is 1, with 10 will give you 0.1. So the maximum amplitude after the division will be 0.1. As you can see here that the maximum amplitude is 0.1, and this is the division you can perform for any other signal as well. Now let's try to perform switching. You can switch two waveforms by giving the switching condition. I have taken the first waveform sinusoidal and the second one is a pulse waveform. you can you can open the switch and you can see here that pass through input 1 when input 2 satisfy the selected criteria, otherwise pass through input 3. The input are numbered top to bottom, that is ऊपर से नीचे की तरफ होंगे. This one is the first input, second input and the third input. The input are numbered top to bottom. The first and the third input port are the data ports where you can apply any signal, and the second input port is the control port. The criteria for control port are U2 that is greater than and equal to threshold. Uh, for a for a particular value of this particular U2, this when the value is greater than this particular value, then it will switch the waveform between these two. So let's take it the constant part and apply it to this and take its value 5 and connect this switch with this signal. When you run it, you can see here that the waveform is only sinusoidal. So the threshold is not maintained. You have to give the threshold value 5 whenever this sorry whenever this signal let's take another signal, that is pulse here, and try to connect it with this. Take here as a zero point 0.5 threshold. I've taken 0.5 as a threshold, and you run it. When the pulse generator waveform is greater than 1, then this will give you the first port output into the scope, and when this value is less than zero point 0.5, this will give you this output into the port, into the scope. So you can see here that the two waveforms are merged by using this particular switch. Here initially the value of pulse is high and will give the sinusoidal waveform into the for the 5 second. For after the 5 second, the value of the pulse is low, it is less than 0.5. It will pass the signal, that is pulse generator first. values. So let's uh, try to make uh, try to plot this with this output waveform. So I have introduced a mux over here. In the first port of the mux, I have applied this, and in the second port, I have applied this pulse. When we connect this with the scope and run it, you can see both the signals. That is, during this pink one is the pulse, that is the threshold, and this is the output, that is output of the switch. During the first half of the, that is first 5 second, you can see here that the pulse width is the threshold is greater than zero point 0.5 and will pass the signal first. You can see here that when this pulse is greater than zero point 0.5, this switch will pass the first signal into the output of the switch. And when threshold is less than, or this pulse is width pulse value is less than this threshold, that is zero point 0.5, this will pass the this pulse generator value onto the switch output. I hope this waveform and this switch concept is clear to you. Let's take another example. Take another operation which we can perform. So try to perform the logical operations. Uh, Logical operation of AND. If you don't did not find any block, you can write it. You can write AND. You can see here that in logical operator, AND operation is there. This is logical AND. You can perform the logical AND operation on two pulses, this and this. Whenever one of the, or whenever both of the inputs are high, this will give you the high result, and otherwise in all the cases the result is 0. So let's change the pulse width 10 to 5. When you run it, first connect a scope over here to check the response. When you run it, this will be the output only for the first 1 second, half of the 1 second. Both the inputs are 1 and will generate the result 1. Overall, other in on all other places, the output is 0. So connect a mux over here to check whether this AND operator perform correctly or not. You just connect here with this and try to change the number of input in this mux to 3, and then pass it to, and connect all the inputs to, when you run it you can see the, now I think there is some error. Input port 1, okay, let's try to remove this error. Let's take it 2. We'll try to run it. Same data type mismatch. Input port 1 of untitled mux 2. Expect a signal of data type double. However, it is driven by a signal or data type boolean. Okay, okay. Since these are the double data type, and this one is the boolean output, so both these two will not be able to enter into it. You have already seen the output of this boolean. When you run it, you can see the output of end. When you see here that during the first zero point 0.5 second, from 0 to zero point 0.5 second, both the values are 1, otherwise it is 1 0 and 0 0. So this will give the output same as uh, this one. So I hope these operations are clear to you. This AND or logical operator, you can convert this into OR, and you can check the response of OR as well. This is the response of OR. Now you can check for other also. You can convert it into NAND. This is the response of NAND. You can change to XOR, XNOR, not any criteria you want, or any logical operation you want. So this is the XOR. These are some of the basic operations which you can perform in this Simulink by using graphical user interface. Now you can also make a transfer function in the Simulink. And you can check its response for any input, whichever you want to check. So I have taken the pulse and applied it to the input of the transfer function. Transfer function is 1 upon s plus 1. And when you run it, this will give you the response of the system for pulse input or square waveform. You can change the transfer function. Let's take 1, 2, and for denominator take 1, 1, and 1. This will convert the transfer function to s plus 2 divided by s square plus s plus 1. And when you apply this input to this, it will give you the result when you run it. When you run it, you can see this is the response for the particular system for pulse input. Now you can change the input from pulse to sinusoidal. Then it will give you the result this. This is the response of the transfer function for particular sinusoidal signal. So let's try to change the signal amplitude to 2 and frequency to 3 and try to change the transfer function as well. When you run it, you can see here that this was the response of this particular system. Now other operations such as you can also calculate the fractional derivative and integration of particular signal. So let's take this fractional derivative. I think this will be added here. We can calculate the fractional derivative of any signal, let's say this sinusoidal signal. 0.5 derivative of this particular signal, that is sinusoidal signal. We run it, this will be the response of the 0.5 derivative of sinusoidal signal. You can change the derivative order from 0.5 to 0.01. When you change to 0.01, it will give you the same sinusoidal signal. When you change it to 10, it will give you 10 time derivative of the signal. So let's take it the value point, or when you take it 1, it will give you cos waveform. So this is the cos waveform. You can make it -1. This will give you the integration. Order should be positive number. We cannot make it negative because this block only support positive value. So let's take another value. Let's example 0.9. Nearly give you cos type of output. Now we can perform fractional integration as well. Remove this derivative and include this fractional integral and change its order to, let's check for 0.5 first. So this is the integration of the sinusoidal for 0.5 order. And this is simply the integration. We have taken the value of order 1, and this will give you the integration of first order. So these are the operations which we can perform on these signals, such as mathematical operations, addition, subtraction, division, multiplication. We can perform the logical operations such as OR, XOR, XNOR, NAND, NOR, NOT. All these operations can be performed on these signals. We can use the switch to switch between the two inputs. So there are more flexibility in Simulink to design anything in graphical interface. You can visualize all these concept in Simulink. Now If you want to draw a XY graph between two inputs, considering one in the X and the other in the Y axis, so I take this as a X axis, or I take this as a X axis and this as a Y axis. This will give you the plot of both these signals. I think this is the plot. And the above one is for X and the lower one is for Y. You can change the minimum and maximum value of X. So let's change to 10, minus 10 to 10. And for Y, let's take minus 10 to 10. You again run it. So this is the graph of X versus Y. This is the Y axis and this is the X axis. So I hope that these basic operations and these blocks or these mathematical operations are clear to you. You can simply save this file by clicking on save as, and you can name it as per your choice. But the name should not match with the function name. For example, you cannot write for. It will give you for is a not a valid model name because it is a MATLAB keyword. Because there is a file uh, in the form of for is stored in MATLAB, so you cannot give name like for or other like I can give board. Board is a function in the MATLAB, so you cannot give board name to this file. You can give board one dot. Dot is not a valid name as you give dot. Dot will not be considered in the name. When you give board one, this will save this file as board one. But you can give any other name as well. You can give like experiment one exp one to this file, and this will automatically save into the file. You can check this file inside this folder. Here you can see this is experiment one is saved and board one is also saved. But I have taken board one. Experiment one is the name for that file. So uh, remove that board one file and take the copy of this experiment one file and include this. So I hope this is clear to you all. We'll meet you in the next lecture and continue our topic that is Simulink for dynamical system. We'll cover this in the remaining lecture, how to design the dynamic system, how to control the dynamic system and other aspect in the Simulink. Thank you very much.